And so far we have almost 50 people. And I would imagine that that means the majority of you guys are benefiting from our virtual lunch reality trip this week. We want to thank the folks at Angry Audio. Mr. Ewell, I see you're here. Try to take a bow. Mike, are you listening?
There we go. Can you hear me, guys?
I can.
Okay.
Hi, Mike.
Hey, guys. I hope most of you got your lunch. If you didn't get your lunch, contact me afterwards. I did get 50 cards, so I do have room for 50 people.
All right. So that's good. So if you signed up, you got enough for your pizza or your sandwich, most likely. Not quite a champagne dinner, but Angry Audio is our happy benefactor today. Meanwhile, we do have a regular sponsor every month is Broadcast Depot, and Mary Shelley is with us. Mary, you're going to tell us about the extra. Mr. Ewell is going to jump back in on us if we're not careful. But you've got a special on the phone flasher and a door prize.
I do. So I think how we'll do this is the first one that emails me will get a free Angry Audio headphone amp. And the email is mary@7bd.com. So include in the email shipping address, and the first one that gets in my box will get the free headphone amp.
Oh boy. So that's a pretty good deal there. $150 or so there, isn't it, Mary?
Yeah.
$219.
$219. We just bought 3 of them for the little LPFM station, and I have to go down and install them. I'm looking forward to that. And one thing that says is it's a lot of power. And I remember Real Don Steele used to have a 50-watt amplifier to drive his headset. And he was as deaf as a doorknob. And one of the things that they always used to fight on KHJ is feedback from his earphones. But that was,
I can imagine.
something.
And you know, I'll throw another thing in there before Mary finishes up. If you've got talent that's really deaf, we do have a headphone processor that will certainly improve the sound of their voice in their headphones and give you a little extra oomph if you need it in that amplifier. So that's the C3, the headphone processor from Chameleon.
Chameleon, yeah.
And back to Mary.
So it looks like we have a winner, Mark Forrest.
All right. Congratulations, Mark. We'll probably do this again in upcoming weeks. So stay tuned. And especially on the Tuesday reminder list, we let you know first about things like the free lunch. And that way, if you get the Tuesday reminder, and all you have to do is send me an email and I'll put you on it. That way you'll be first in line should we have more than 50 folks sign up or whatever. Quick note, KELS got a $15,000 fine for running 1,600 spots over 3 months. The problem, they're an LP FM station, not supposed to run spots, and they got turned in. Next week, we're going to talk about remote control with the TX control that comes from 22HBG, which came out of the Elenos group. So you'll want to check in on that. But this week, we really are pleased to have Tom LaBarge back with us. Tom is head of the GroundLinx company that has investigated and produced products that are different from the traditional ones that broadcasters have thought of in terms of grounding and lightning suppression. It's more than just number 10 copper cable, but Tom has looked further. And he has found that some of his clients used to get damage every single time there was a lightning storm, and they're not getting damaged now.
We're down to zero.
So let's talk to Tom, find out what he's doing, and you can ask questions of him to see if you can get yourself damage free. Hi, Tom.
Good afternoon, y'all. And that's a Southern phrase, by the way. How many Southerners we have here? Not too many. Oh, there. Yeah, hey, Ken. I've talked to you before, I believe. Grounding, talking about grounding and lightning protection is pretty much as exciting as talking about paint drying or watching paint dry, and I understand that. But when lightning hits, and when it comes in and comes in a variety of ways, it's not just a tower strike. A lot of things can go wrong in a real. Oh, did I put Brian asleep already? Look at that. I think I've nope, haven't bored you to death. Okay. Of course, when lightning hits, a lot of bad things happen. And what we have developed at GroundLinx started out, and some of you have heard some of this before. I'll try to go over it very quickly. GroundLinx started because my house got hit by lightning, and virtually everything electronic in the house was destroyed. What surprised me about that, it was just everything electronic. In fact, when the house was being built, and I wired it, but I leave the outside wiring to professionals. There was an electrician outside pounding in some long rods in the ground, and I had never seen those before. And I yelled down to him from the deck, and I said, "What are those?" And he looked up at me and he said, "They're called ground rods." I said, "What do they do?" And he says, "I don't know. We just have to put them in." Well, a year later, they didn't work because all my electronic devices were fried. Cable boxes, computers, TVs, refrigerator, washer, dryer, a whole bunch of things. Happily, the wiring was all good. We were able to check that, and so that wasn't a problem. What I was after with that is that why would electronics be the victim of a lightning strike? So I set out to come up with a better solution to grounding, and what we came up with, it was in one of my barns, and I was in the barn when the lightning came again and hit the barn, and nothing happened this time. We had our prototypes in the ground at that point. So I called my partner, one of my partners, and said, "Get your butt over here. We've got something." And what we did was we maximized the number of emitting points. And this is one of the things Barry wanted me to talk about. We maximized the number of emitting points for power to get into the earth by using carbon fiber, is one thing. Which is zillions and zillions of endpoints. And then we use copper mesh, which has many, many feet of edges. And we put those together with some other materials that I can't tell you about. And we ended up with each of our electrodes that we bury in the ground having approximately 18 million paths away from the electrode. A ground rod has one. Now, all the engineering text that you all have seen will show what's called spheres of influence around a ground rod. And by the way, I don't have any graphics to show on this presentation. It came together pretty quickly, so I apologize for no graphics. It's just going to be me talking. But you've seen the drawing of spheres of influence, probably. Nice concentric hemispherical shapes around a ground rod. I had a little trouble believing that because it assumes that the soil you're putting the ground rod into is perfectly uniform throughout the depth. That's obviously not the case. The next thing that I had trouble with was, why would charge emanate from a conductor into really crappy conductivity soil? And the resistivity of soil is about 1 trillion times higher than that of copper. Why would it do that uniformly down the length of a ground rod? So to find out whether there was any truth to spheres of influence, I got myself a fancy fall of potential meter and set out next to the barn to pound in a ground rod, and I measured the resistance or resistivity every 6 inches of depth. If the sphere of influence rule is correct, every inch or centimeter or whatever I go into the ground, my resistance should go down because there's more copper in the ground. That worked for about 2 feet. Then it started to go up. And then at 43.5 inches, we hit rock. And sure enough, resistance to ground went to 2,800 ohms. The moment it hit rock, it took off like a shot. Well, the only way that can happen is if all the emission of the grounding signal is happening at the tip of the ground rod. In fact, from 24 inches up to 40 inches, 36 to 42, and again, every 6 inches, the resistance slowly climbed. So I was obviously going into different soil. But why would it go up with more copper in the ground? I repeated the test in Michigan, Ohio, and North Carolina. Got the same basic results. It all depends on the soil you're going into. So now I've got a ground rod that's emitting almost everything, not all, but almost all of it at the tip. I'm not really happy with that as a way to get rid of 30,000 amps and 250,000 volts. I would much rather it be spread out over many, many points. So that helped us fine tune our particular product to the point where we have 18 million paths. And that's even made to a bigger number with the material we surround the electrode with, which we call spectrum. We were able to prove the viability of our approach to grounding by actual commercial installations. And I think I've shown you all this picture before, and I can't very well show it now, but we did a broadcast tower in Richmond, Virginia, channel 6 WTVR. And it's since we were there, they've been hit 5 times directly. One was photographed. I went back and dug up one of the electrodes near the tower to see if it had been badly damaged after 2 strikes. It looked brand new. And what I thought was fascinating about that is obviously we're dissipating this charge very, very well. So there's no heat buildup. It's getting gone, and there's no damage to the station's electronics. Prior to our grounding there, they were losing about $20,000 to $25,000 of equipment every strike. If I showed you how this 843-foot tower was grounded before, you'd know exactly why that was happening. They were using a galvanized fence post in steel, in concrete, with a number 6 wire to ground an 843-foot tower. Not a real good idea. And what was happening at the site is the tower would take a hit. It couldn't go to ground, so it would air gap from the tower. And we have witnesses to this. 2 Richmond police officers volunteered this to me over time. It would air gap from near the base of the tower over to air conditioning units on the studio roof. At that point, it was in the neutral inside the building, and it was game over. Anywhere the neutral was, anything was plugged in, was now on the receiving end of their stuff. They haven't had a single dollar's loss since we've been there, which is a wonderful thing. So the key thing in the broadcast business is what most of the work we do is with 911 centers and other mission critical facilities, not so much broadcasters. We're not cheap. That's part of the problem. But we do save you a lot of money. I guess the average broadcast installation we've done has been around $45,000 to $50,000. So it's not inexpensive. Anyway, we do a lot of mission critical facilities, and again, they don't have the option of going off the air. I think commercial broadcasters, you don't want to go off the air either. That's really, really bad. And do I see any agreement on that? I don't see anybody nodding their heads or anything. So, yeah, they're okay. George said yes. Anyway, the whole idea is to make a better, more efficient dissipation of power, and the approach that we've taken. And again, I wish I could show it to you, but I just don't have the graphics. Couldn't get the graphics together fast enough. Or maybe I can. Let me see if I've got a photograph here. There you go. So that's a close-up of one of our larger electrodes. And you can see the carbon fiber in there, which is made of many, many thousands of very, very tiny fibers. Carbon fiber, believe it or not, and many people don't realize this, is extremely conductive. It's the same stuff that's in the spark plug wires in your car if you have a gasoline powered car. When this is energized by a lightning strike, every endpoint in every one of those fibers becomes an emitting point. That's what we found. And again, we don't find any damage to our equipment. I've dug them up 4 times now after lightning strikes, and we haven't found any indication of there being any damage, which is a lot of fun. Barry, you wanted me to talk about another thing that was going on. I think it was we're finding, because of these devices and they're so efficient at getting rid of charge, we're finding that, and Brian's got another vehicle up there now. another locomotive. We're finding that this is anecdotal reports from our customers. And I'd love to hear your all's input on this. Maybe you can help me figure out why this is going on. But one of our biggest customers is claiming that he no longer has static buildup on his towers from wind or anything else, to the point where he's getting better SN ratios. And the only thing he can trace that to is he had greater static before we were there than now. He's got 12 mission critical towers. We've grounded all of them. He has not had a single lightning strike until a week ago, and that's over a 2.5-year period. Prior to that, he was being hit 3, 4, 5 times a year at each tower. Now it's down to 0. His hypothesis on this is because there's no static buildup on the towers, and in other words, our grounding device is taking it off the tower. There's no leader that can form to match with a passing negative cloud and get a lightning strike. Does that make sense to any of y'all? That if we can get rid of static on a tower, it's. You know, I'm not a radio engineer. I'm nothing more than a business development guy that did a lot of research on grounding and found out that we've got a great product. Does that? I'm seeing a couple nods here. Does that seem to follow at all?
He changed religions.
He's also, another customer is saying that the voice transmissions, and he sent me tapes on it, and I agree, voice transmission of his dispatches, another 911 customer, voice transitions are clearer, there's less noise. I guess that could be if you're preventing issues getting on the tower, that's going to make the actual signal a little cleaner. Does that make sense to anybody? I'm not seeing any nods of approval there.
Well, I'll give you a nod of approval for that, Tom. Yeah, obviously, when we have static on the tower, just like RF, it can rotate back into the transmitter and it create noise on the output. So that's very much an issue. I'd like you also to talk about the ground rods themselves that most systems depend upon. And maybe those ground rods have been there for 30 or 40 years.
Yeah, that's a good point. Have any of you gone to Home Depot or Lowe's or your hardware store of choice and picked up a ground rod and looked at the fine print on the label? Probably not. It's not something most people do. If you read,
copper one?
Yeah. Copper's fine. Yeah. Galvanized would have the same sticker on. In fact, the number's probably less. On a galvanized ground rod, you will see a sticker with the UL mark and so on and so forth, and it will say replace every 10 years.
Oh.
How many people have ever thought about replacing a ground rod at their house? Doesn't happen. The esteemed U.S. Navy did a very famous test out in the Nevada desert, which they wanted to use because it's dry. Relatively dry. What's that, about 4 inches of rain a year in Las Vegas, I think. And they put in a copper clad ground rod, a solid copper ground rod, and a galvanized ground rod, and went away for 7 years, and then came back and dug them up. The solid copper rod was doing fine. Of course, they're extremely expensive, but it was doing fine. It had some issues with its surface area. The copper clad ground rod on galvanized, or on steel rather, was nothing more than a copper sheath. The steel was gone. There was just a very thin layer of copper in the ground. The galvanized rod, 7 years down the road, was gone. Just didn't exist. So that gives you an idea. If you have a grounding system that's been in place at your facility for more than 10 or 12 years, the odds are pretty strong that it's not performing the way it should. And we've gone by that, and we've found at various sites we've been to where grounding has been ignored, as it almost always is, both inside your facility and out. Nobody pays attention to those green wires.
So how do you test it, Tom? Do you take your voltometer and test the tower to ground?
Well, you can check resistance to ground. That's a good guideline that something's not working right if it's a huge number. But it's what I did in Florida at one particular location on a spit of land called Cape San Blas. It's near Port St. Joe, if anybody's familiar with that part of Florida. There you go. There's a wave. Before Hurricane Michael hit, actually about 3 weeks before Hurricane Michael came in, I was going out to do some photography on Cape San Blas, and I stopped at a convenience store just before the opening of the state park, or the beginning of the state park, and wanted to get a couple bottles of water. Being in this business, I noticed on the convenience store, it had a brand new weatherhead and brand new electric service. Well, that was kind of odd because the convenience store had been there for a long time, but there was brand new service. Well, I went back to the truck and got out my handy AEMC 6417 resistance to ground resistance meter, a clamp on, and clamped onto the ground coming from the meter, brand new ground wire. And it said, conveniently, 4 ohms to ground. Wow, isn't that great? Well, I'm at an elevation of 4 feet above sea level. So there's a ground rod, and it was down in the salt water, certainly in the brackish ground. So it was a great grounding system. Well, then my eyeball went up the service pole to the weatherhead and transited over to the transformer about 20 yards away, up on a pole. And it was kind of haggard. It had been there a while. Of course, anything metal in Florida is going to have a bad day, especially if you're near the ocean. So I walked over to the pole with my 6417 and clamped on to the ground, right to the ground wire, right at the base of the pole. And it came up 1,000 ohms to ground. I said, well, that's kind of odd. I got 4 ohms to ground over here, and I got 1,000 here. And I'm 20 yards away. It's all sand. It's still salty, brackish water. So I grabbed onto the ground wire that was, you could see a little bit of an acorn clamping onto a ground rod. And I pulled on it, and up came a 7-inch long ground rod. That was it. The salt water had eaten the grounding completely. So that's why I was getting 1,000 ohms to ground. That's a good way to check your grounding system. Yank on the ground wires and see what you get. If it's loose and rattling around, you got a problem. If it's corroded, and it will almost always corrode if there's any current going through it at all, the connection between the acorn clamp or the bonding device to your ground rod will be terrible and may need to be replaced. Those are good simple little tricks to do. Another thing that surprises me about ground rods, and we've actually been challenged on this. I was out in West Texas pitching our product to a major oil and gas producer, and it sounds like they're going to actually buy a bunch of them, which is wonderful. But I was out there, and one of their engineers said, "Are you telling me electricity has momentum?" And I'm saying, well, no, there's no mass there of any consequence, but it behaves like it has momentum. What am I getting at? Electricians' books and code says you take the grounding lead, the number 6 wire, and you have it come up the ground rod and connect to an acorn clamp this way. And here's the end of the ground rod here. So it's coming up this way. That's what the book says to do. Well, that's asking a whole bunch of juice to come up that wire and make a 180-degree turn and go down to a copper ground rod or copper clad or whatever that it really doesn't want to go down anyway, because there's no place for it to go after it gets down to the bottom of that ground rod, especially if it's in crappy soil. You're asking it to do all kinds of gymnastics, and it's not going to do that. It's going to reflect back. You will have reflections, and you can prove that with a TDR. So the guy out in Texas said, it's got momentum. I said, well, yeah. Have you ever seen an LB box? You know what everybody knows what LB box is? A electrical connection box that it's a kind of oval. Usually they're gray plastic at your service entrance. Hopefully people are knowing what this is. The conductor from a transformer, big, heavy cable, right? Comes up into an LB box. It's got a cover on it, and then it turns 90 degrees and goes into your panel inside your building, typically. We've seen in numerous cases where the top of that LB box has a hole blown in it, just gone, because a lightning bolt came in on service and couldn't make that tight turn, and it blew the top of the plastic right out. It was singed, and we find the remnants of the plastic on the ground nearby. That's pretty amazing stuff.
Does lightning travel any faster than 186,000?
And the presentation I was just listening to at Chapter 60 of SBE in Richmond, Virginia, the presenter there, who owns a lightning protection company, said the Lightning Protection Institute says 90,000 miles an hour, miles a second. So roughly half the speed of light. I have no way of knowing whether there's any truth to that or not. It's a whole bunch of energy that doesn't have appreciable mass, but in the volumes that's coming along, maybe there is enough mass to cause a problem at that velocity. But I've actually seen them with my own eyes multiple times, LB boxes with the ends blown out of them. And that can only happen if there's some serious back pressure. Anyway, on your ground rods, since most of your facilities, and I see a lot of hams here, certainly you have ground rods all around your towers. Take a careful look at them if you want to get some better performance. If you really want great performance, talk to us. We'll get you. We'll get you with an even better signal. Another one of our customers is putting in, and this is way past my pay grade, is putting in a Ballon antenna. Does that sound familiar to everybody? A balanced, unbalanced antenna? And he added our grounds to it, and he says he's getting incredible performance because the ground plane between the two ends of that antenna, when you make that really, really effective, it gets to be a big benefit to your transmission, apparently. I see a hand.
Tom, Don Elliott, can you tell us possible benefits to an AM site radial conductivity improvement?
We believe that it's there. That's what we're finding out from this, from the gentleman in Mobile with this Ballon antenna. That's basically an AM. The way he explains it, it's HF, but it's AM. Is that correct? Am I telling tales out of school, or can you confirm that? He's a ham, and he says it is HF, but it's behaving like a ground plane in an AM tower. Does that? He says yes. How about that?
Got a lot of radials at an AM though. I mean, do you have to put a couple of hundred of these in at the end of the radial, or at the tower base?
I don't believe so, because we're so much more effective than ground rods. Because what you're at the end of the radial, you're putting a ground rod. Is that correct in an AM installation?
I think he was an AM ham is what it was.
Okay.
I meant AM broadcast.
In an AM broadcast, you have numerous radials, and there's a ground rod at the end of each radial. Is that the typical, or is it just a radial?
Just a radial.
There are radials buried under the ground, going out.
Right. Every 5 degrees or 10 degrees?
3 degrees, typically 120 long ones around a quarter wave and 120 short ones.
Wow.
Well, that's a lot of ground rods.
Or ground wires. Oops, what do we got here? There we go. We're back now. I don't know what that was that came up. It wasn't me. We haven't ever tested it in that situation, but I got to believe, since we have been able to prove the effectiveness of our grounding devices, meaning they are super dissipators, they've got to be producing a much better grounding plane.
Yeah, I just would be worried about it affecting the pattern. If you've got 1 or 2 kits in, and it changes if you're non-directional, it would change the shape maybe, or if you're directional, it might screw things up. I don't know. I'm glad Don started that conversation, because
yeah, we'd love to find out as well. And we'll be happy to contribute devices if anybody wants to try it and do some research.
Did I see Tom King on the invite list? Good one for him.
Tom
at Kintronics.
As far as I know,
this is one of those.
here.
Yeah, this is not it's funny, for as long as we've been doing radial ground systems, there are a few things we don't exactly understand. A lot of it is we have always done it this way. There are also some stations that have elevated ground systems, and sometimes as few as 4 or 6 or 8 elevated wires. And you read the efficiency of those, they work about as well as the big radial systems. And you begin to wonder, you wonder, all right, where did it go? What was the difference? When you were talking earlier about improving the signal to noise by getting rid of the static, that part makes total sense. But I wonder why static on a tower doesn't dissipate like static on your workbench. If you're handling small parts, you wear the little number 16 wire to the wristband, and all that matters is that there's a ground connect or a drain connection. This may be thousands of ohms, tens of thousands of ohms to ground, but it's just a place for the static to go.
Yeah, it's a good observation. All I can think of is that in the case of a tower, if there's any wind at all, especially if you have a dielectric on it in the form of paint, you're going to have a consistent buildup of static constantly. I mean, constantly. It's going to keep coming, and that may be part of the answer there. I'm not going to profess to know the answers to many of these things. Our little grounding device, and we've got a newer one that's smaller, that's even more efficient in size, but it keeps doing things that we didn't expect it to do in a good way. And when we started to hear this SN issue, also with the transmission quality, the voice quality on 911 calls or dispatches, that made us real happy, because that's got lives in the balance. And if you've got a super clear transmission going out as opposed to one that's got static and other garbage on it, that's a problem. That brings me to another thing I'd love to talk about.
Before you do, let me just bring back something you said to me in our conversation, that not all of the static or lightning is one frequency. It's not.
Yes. Yeah, I cut you off there. The first, believe it or not, 8 microseconds of a lightning strike. That's where research shows the peak energy occurs, between 0 and 8 microseconds. So 8 millionths of a second. In that 8 millionths of a second, frequencies, there are AC characteristics in lightning. It's not an AC current necessarily. It's primarily static, primarily DC, but it does have a cacophony. Am I saying that word right? I think that's right. A cacophony of frequencies in it that can exceed 250 megahertz. That's a problem for copper. Copper, as a conductor, starts to lose its effectiveness as a conductor, and especially as a dissipator, above 100 megahertz. It still does, but it doesn't do it as well. That's one reason why we think our units are so much more effective, is because carbon fiber starts to turn on at about 60 megahertz and can go higher and higher and higher. So we're covering that entire range of frequencies in that most critical point, that first 8 milliseconds or microseconds.
So the carbon either has no skin effect or less of a skin effect than the copper, because as the frequency goes up for copper, you're on the surface more and more, and soon you're a 1 molecule deep layer, and just the resistance goes up.
That's what we're finding. A lot of that came from the gentleman that's now our chief scientist, and he retired from Boeing. His job at Boeing was making aircraft safe from lightning, and he did a lot of research with carbon fiber, and has helped us refine our design so that it works a little bit better to take the benefits of copper and carbon fiber combined, so that the frequencies are all managed, and the skin effect is taken care of much more effectively. We think that's what's happening. If you can tell me a way to test that, I'll be happy to test it, but all we can go on is our empirical evidence of what's happening in the field right now. So the high frequencies are a big issue, and those all live at the front of that event in the steep wave part of a lightning strike. We like to brag that because we have empirical evidence, our the high frequencies are being consumed, the very high frequencies are being consumed by our device and not being reflected back into your electronics. And that's a bad thing, of course, and then the smoke comes out of the box, and nobody wants smoke coming out of the box. That's a really bad thing. What I was going to get at, does that answer your question, Barry?
Yes. Mm-hmm.
Okay. Or is that sufficient for everybody? That's again, I can't say this with empirical certainty, other than we know it's working. I can't give you white papers with university research on it. The other thing I wanted to talk about, and this is really important as far as how your facilities are managing lightning issues and grounding issues. In our experience, and it's a whopping 4 years now, in our experience, damage to broadcasters' facilities, whether they're commercial or government or 911 or anything, damage to broadcasters' facilities is only caused by lightning direct strikes to towers and structures 30% of the time, 30 to 35% of the time. 65 to 70% of the damage is referred into the facility via commercial power. Dirty commercial power is a really, really bad thing. And the biggest problem with that is there is no protection on commercial power other than a ground rod at your meter base or at your serving transformer or at the pole that has your serving transformers. And ground rods, single ground rods, just aren't enough to handle lightning at all. So, and then even worse than that, the protective devices that are on a utility, on electric distribution systems, they're called cutouts. You maybe you've seen them, little C-shaped devices that pop a fuse open when it gets too hot. There are things called cutouts they're called reclosers. They're on the system. They're mechanical. They're based on heat. They react very, very slowly. They are all on the phase lines. So the utilities will do a lot to try to protect from surges on the phase lines. But the neutral line has nothing on it other than a ground rod. You have a lightning strike that happens anywhere near a power line, it's going to induce current in the neutral. And it's going to go in both directions. It's not going one direction or the other. It's metal. It's a conductor. It's going to travel one way or the other from the point of concentration of the power away from it, guaranteed. Well, that neutral line has a direct route right into your building. All it can pass is a ground rod at the meter base, or again, if you have a pad mounted transformer, there'll be a ground rod underneath there. If it gets past that, it's inside your building. Now the situation gets worse. Oh, I've got surge protectors or surge suppressors. Well, the people I know in that business tell me that 99.9% of surge suppressors are not connected to the neutral. They're only connected to phase lines. So now you've got a major surge inside your building, past your surge suppressor. Smoke's going to come out of the box. Really, really want as many people as I can get to start to look at the grounding on their commercial power. Now they won't let you do it other than at your meter base. But it's better to go out to their pole or their transformer and say, hey, put some better grounding on this. They still won't do it. The utilities won't do that. We found that out. However, I do have two utilities here in North Georgia and Eastern Tennessee that have agreed to allow us to put our devices at any customer pole.
How does this impact your insurance?
Insurance people are starting to pay attention, but the big guys are not. We work very closely with a company called VFIS, which is Volunteer Firemen's Insurance Service. They are the largest insurer of municipal emergency operations and municipalities, including sewage treatment plants, believe it or not, also municipal hospitals. So it's a very big company, the biggest in the country, and they are now requesting that for people that have had multiple claims to have a grounding audit done and ideally consider a much better grounding system. That would be us, of course, but they can't specify us for a variety of reasons. Did I see a hand come up down there? Or that was, no, okay.
Have you patented this?
Yes, we have patents in 33 countries, 4 patents in 33 countries. So this is going to get pretty big at some point based on the experience we're seeing with our customers. We literally have had $0 of damage at any of our installed sites and 0 seconds of off-air time. Hasn't happened. So we're pretty proud of that. Go ahead.
Okay, so we've talked about copper deteriorating and et cetera. So what's the life expectancy of this system?
I'm going to put it at least 10 years. The carbon fiber will be there until the cows come home.
Okay.
The copper is much thicker. We use a minimum of 0.050 or 0.05 of an inch on our electrodes. That's going to be in the ground for a long time. In a case of a copper clad ground rod, you're talking about a couple microns.
Okay.
So I'm going to say at least 10 years.
How deep are you going with the install?
Great question. Great question. Depth is not important to us because we don't require moisture to work.
Okay.
Ground rods have to have moist soil to work. Our big electrodes, which are 18 inches tall and 13 inches wide, We put those in at the bottom of the unit is at 30 inches. And we have no problems at all. Our first go ahead.
Go ahead. No, go ahead.
Our very first installation was for KBZK in Bozeman, Montana.
Okay.
I had to do that myself, and I've done most of the installations myself, as it turns out. But I'm not a fan of Montana in January. Well, we were at 7,500 feet. The soil was frozen solid at 24 inches. Now, everybody knows that frozen ground is not a good conductor because there's no water to work with. Well, we put our system in there. We had to use a jackhammer on the excavator to open up 18 holes where we put our electrodes. You know, this is for a tower, a transmitter shack, and a generator, all connected with a big ring. So there were 18 electrodes in place in frozen soil at 30 inches at the bottom. The existing ground rod system, I put a clamp-on meter on, and I got 294 ohms to ground. I switched the wires over to our system, and I got 6.4.
Here's a grounding nightmare story.
Go. I'd love to hear it.
Okay, so we're building a church, of all things. I got involved in the construction project, large church. Not paying attention, the contractor put the ground rod in the basement. When they poured the basement slab, they left a 12-inch by 12-inch spot bare, and it was dirt. So they pounded the ground rod into that and attached it and thought that was 12-foot ground rod. And so on certain Sundays, the sound system would start to hum.
Imagine that.
And they would go downstairs and pour a gallon or two of water on the ground rod.
I can't tell you the number of places I've seen
Holy
ground
water.
rods installed in absolutely bone dry earth to the point where
In the
we'll never.
basement,
Yeah.
center of the basement, concrete all around it, 50,000 square feet building.
WTVR in Richmond, Channel 6, their entire master control room was grounded with 3 ground rods driven through concrete in a closet. That's a problem. Jonathan, you muted.
No, I know I was done. That's funny. That's a funny story.
It's just they're real happy with us, it turns out, just because they don't have any losses. And when you're losing $30,000 every year, and now you're not losing any, that's kind of a good thing. That helps out. Walker County, Alabama. That's Jasper, Alabama. If anybody knows where Jasper, Alabama is, a little bit northwest of Birmingham. They were having a problem with, he's got a 307-foot tower, self-supporter. For some reason, lightning was not hitting it. It was traditionally grounded. But he was losing 50 plus thousand each time they had a problem. And all of it was coming on inbound power. And I got there, took a look at it, and I said, well, there's your problem right there. And we put our system in, and he is at 0 now. He's foregone probably $200,000 of losses now, just because we paid attention to the inbound power. I was going to talk about that when we were mentioning transmitters earlier and noise on transmitters. I asked this of Barry, and he seemed to answer it affirmatively. Maybe y'all can give me some additional guidance on this. Can noisy power, commercial power, supplying power to a transmitter, can that cause problems in the transmitter and the transmission quality? I see a couple nods. If that's the case, then putting much more effective grounding on your inbound power is a really, really good thing if it helps clean up your transmissions. That's what I would think. Last thing I wanted to bring up, and I mentioned this to Barry, was with this geomagnetic storm that happened a couple weeks ago, which apparently was a whopper. 2 of my customers reported no issues whatsoever. And that was quite surprising to us. Does that make any sense that better grounding would be helpful in elimination of issues from geomagnetic storms? I mean, a GM, as I'm just calling a GM for short, it's pretty much a really tiny baby EMP. Is that correct? Does that make sense for you hams out there? I'm not hearing anything, so I'm thinking that a better ground can be of benefit to preventing the issues that geomagnetic storms can cause as far as transmission. Now, most of that's going to be an interference with the actual wave of the transmission. Is that correct? That's what I'm reading anyway. Does it make any sense that a cleaner power and a cleaner tower is going to make it less of a problem when in the middle of a geomagnetic storm? Does that make any sense? I'd love to hear any thoughts on that. Feel free to send me emails, and Barry has my email. Would love to hear any thoughts on that.
Do they affect medium wave signals so much as high frequency?
The question again was?
Well, do the geomagnetic storms affect medium wave frequencies as opposed to HF?
They do. Okay, that you're saying that affirmatively. Okay.
No, I'm asking.
Oh, I do not have the information. Can anybody respond to that in the group? I hear nothing. So we have to do some more research on that. What I've been told is from hams have told me that they have problems, but that's HF, right? Or that medium wave.
Well, they can be medium wave, very long wave, okay. HF, VHF, but yeah, mostly you're probably talking about HF. That's where the conditions are prevalent, or dependent on ionospheric conditions and stuff. So.
Okay.
And usually a very different antenna type than AM broadcast.
Yeah.
Okay. Okay. Again, I apologize. I'm not a radio engineer, and I'm learning this as fast as I can to be of more value to your community. And this is the people I'm talking with here are primarily radio. Is that correct? You're not television?
It's a mixture, but it's AM and FM. Usually on AM, in most cases, not all, the actual tower is not grounded. It is actually the vertical radiating element of the antenna system.
Okay.
It's like the old CBs where you saw one pole going up and then you had these radials sticking out on the bottom. That's how the AM antennas work. The vertical tower is sitting on an insulator.
Right. I've seen that at WSM in Nashville.
Yeah, typically it's half of the antenna. Its reflected image in the ground plane is the other half.
Okay, and then you've got
radials you saw sticking out on the bottom of those CB antennas. That's the radials that are buried in the ground, and then the vertical is that vertical rod.
Okay.
And for two-way radio, once you hit VHF, especially at UHF, but at VHF, the wavelengths are short enough that the vertical radiator is half the antenna, and the plane of the body of the car is the ground plane. It's not really a ground because it's insulated from Earth, but it's electrically large compared to the vertical radiator.
Well,
that's all done simply to keep the signal along the curvature of the Earth instead of just going out into space. That's why they call it a ground plane.
Really? Well, that's interesting. I've seen AM towers that have, what do they call them?
Looking for counterpoise?
No, Jerry balls they're called, or something like that.
Johnny balls.
Johnny balls. I was close.
Different thing. It's to keep the wires short enough, the guy wires short enough that they don't radiate the signal. You need an eighth of wave or less so that, they don't act like just more antenna.
Well, you don't want an AM tower, the vertical attracting lightning and then poisoning your ground plane.
Also, you'll see the guy wires on the radiating vertical AM towers have insulators in them. Yes. That's because they don't want the guy wires to short the antenna to ground.
Correct. Yeah. Okay. So it's got to be two separate pieces, obviously. And well, it's.
And then sometimes you will find megohm resistors across each Johnny ball, so it doesn't work well as a radiator, but it drains the static off the guy wires, because otherwise it will build up arc across the insulators and eventually chew up the wires.
Yeah. Electricity will do some pretty amazing things to conductors if you give it a chance.
I've had a couple of towers where
the static choke inside the tuning tower. The tuning box too. Static drain.
What else can I talk to you about. I've got a call. I've got to make it 3 o'clock, so I'm about 6 minutes away from that. And I would love to answer any other questions that I can. I can put the call off a little bit too. I can easily do that.
What do your systems look like physically, or how do you install?
The big unit that I showed you a little sample of, that, well, gosh, I'm hearing a bunch of noise now, and I finally realized what it is. There is a torrential rain coming down on my steel roof now, and hopefully y'all can't hear it. It's 13 inches in diameter, and we typically auger an 18-inch hole down 30 inches, drop the electrode in. Let me see if I can find or maybe you can see it. I'll just put it on I can find it on my cell phone very quickly here.
Is your steel roof grounded through one?
Yes, this building is extremely well grounded. I'm at our factory here right now, and it is extremely well grounded. Thank you very much. The building steel, the electrical systems, the inbound power, the 3-phase power. Yeah, if a lightning bolt gets near here, it's not coming inside the building. I can assure you of that. I've got a good image here of an installed unit, and maybe you can see this. You see the round thing, and then there's that focuses better right there, I guess. It's 2-aught wire that we use as a minimum, and then the gray paste is it's primarily bentonite clay, so there's always a moisture supply, but it's got a lot of other good stuff in it, and it tends to turn the entire electrode with 10 gallons of that paste into a pretty big capacitor. So it charges up for just an instant, and uniformly energizes the entire electrode. Then you see a black ring around it. That's a organic material that we make as well. It has a bunch of goodies in it that causes what we call a greater impedance match. Now, the difference in impedance between copper and native soil it's a disaster anywhere in the world. In fact, some research says the difference in impedance and resistivity between copper and native soil is 1 trillion times. Well, if you're that's a big number, except in Washington. It doesn't count in Washington, D.C. I'll get some better material, I promise. If you're an electron in copper and you're running at the speed of light, and your name is Bob, and Bill's behind you kicking in the butt, because that's what electrons do. And are you going to suddenly turn left up Poughkeepsie and go into soil? Yeah, you want to go to soil, but if the impedance is really, really high, what we find is this is what's causing damage to electronics. We get a reflection off the bottom of the ground rod, and it bounces right back up. It doesn't go into soil. By making this impedance matching material that we make, there are 3 or 4 different layers of materials inside the black material that makes it much more enticing for an electron to leave the grounding device and enter the soil. That makes for much, much greater dissipation, no heat buildup. As I mentioned earlier, we dig these things up, they look like they're brand new. So there's no heat buildup at all. And I just realized the windows to my truck are open. This is not going to be good.
What does one of the units like you just described cost?
We are the big one, and this is installed everything, the ring, they average around $3,000 a piece. It's kind of high, but we're not making a pile of money out, that's for sure. That's with all trenching, all return of the site to the way it was, or pretty close to the way it was. It's up to 2,000 feet typically of 2-aught cable, which is not cheap anymore, as we all know. So that's all in. The average commercial installation has been around, as I say, around $40,000. Our new system, newest product size, doesn't have the separate gray paste that I showed here. It doesn't have the separate stuff, doesn't have the separate black stuff. It's all molded onto a much smaller electrode. It's one piece. It takes about 8 minutes to put in the ground. You auger an 8-inch hole, dropped it down 18 inches, not 30. The pigtails are already attached. Then you just hook it up to a ground ring, ground wire, any kind of lead you want, ideally at equipotential. And it takes more of them. It takes about twice as many to be as effective as the big units. but they're much, much easier to put in and they're much less expensive. So
if a radio station wanted to get started to move away from ground rods and wanted to investigate your product, how could they get started? Where would this $3,000 be the minimum that they could spend, or?
Well, that's just one electrode. Yeah. It'd be, well, by the time we only allow installation by people that are approved by us and licensed by us.
If you've got a grounding stake and you just want to replace it with one of your units, for starters.
I can work with you. I can work
with you. What would that cost?
By the time with the freight, it's going to be a little over $3,000.
A lot of us hams would like to take advantage of that, you see.
A lot of us, whom again? The rain is so loud, I couldn't hear that. I apologize.
I said a lot of us ham radio types would like to take advantage of
Hey,
that.
give us a group ham rate. That'd be great.
I'll be more than happy to work with you.
Exactly.
You can reach me. My name is showing up on the screen there. Run that together into one word. Tom LaBarge at GroundLinx, GroundLinx. There it is, .com. Barry's so good. Man, oh man, is he fast.
Tom, as a point of clarification, you mentioned an LB box. Technically, it's an LB conduit body, since it's part of the conduit system.
Okay.
But I'm just being picky.
I stand corrected.
Now, you can do splices in them by code, but technically it's not a box.
Yes, that's correct. I misspoke.
I made this point the last time you talked to us, that at least in school and when I talk to people in the power distribution part of the world, they're reminding us all the time that about 15% of the power that leaves a generating facility returns through the ground.
Correct.
And that makes things really interesting as far as the clean communication or the clean topology that you're trying to talk about, and how really dirty power is in general.
I can't disagree with any of what you've said. That's what we hear.
Yeah. I know they warned us not to walk around unless we're hopping when we get close to the big generators on the
transformers. Yeah, we don't want to have a step voltage develop that goes up one leg and down the other. Because your heart's going to say hello.
Yeah. Ken had mentioned replacing. I don't think code's going to allow you to replace a ground rod because code's going to call for it, but putting your system in addition to or parallel to. Good point. Makes sense.
Good point. In our earliest days, we added a ground rod right through the middle of our electrodes just to make sure we were in code compliance. As it turns out, as long as there's one ground rod, ideally two, on site somewhere that's hooked into the system equipotentially, we're in code. 99% of our installations are supplemental. We do not ever take out any existing grounding. We do not disconnect any existing grounding at all. We only add. And what we say is all ground is a good ground. Some ground's better than others.
Yeah,
and that's what we try to do. So
like
yes,
redheads.
absolutely.
Like redheads.
I knew I liked this group.
Yeah, I think any of the auxiliary grounding that I've done for signal and whatnot, for getting really quiet audio and whatnot, the inspectors don't like you changing anything. They just want you to add.
And what's wrong with that? Mm-hmm. The more ways you have for a fault to get to ground, the better. Just that simple. Whether it's a fault or whether it's noise or whether it's something to improve your transmission, the more ways you have to get rid of it, the better.
This will be interesting to see how this evolves.
We're
learning all the time.
Absolutely. But what gets us the most, what really bothers us the most, is that traditional grounding hasn't changed at all in 50 years. And actually the last major patent, it wasn't the ChemRod. Maybe you've seen those advertisements. There are a couple companies that say, hey, we invented the ChemRod. Well, no, you didn't. It was patented. The ChemRod was patented in 1931. The last major change to grounding was the UFR ground, which is using rebar in concrete.
I was going to say that's a change. Yeah.
That was in 1943.
And they didn't push that until I was out of school in the 70s.
It actually became part of the NEC in 1968. Now there are counties pushing it because contractors love it. It's cheap. You hook onto to the rebar, and then of course when the lightning strike hits 2 years later, the builder's nowhere to be found. But you've got a cracked foundation. There's always residual moisture in concrete.
Right.
You put a big jolt. Well, you know why? Fun story. The inventor of the UFR ground was a guy named Herbert UFR. I mean, they didn't just take 4 letters and put it together. Herbert UFR, that's the guy. I see Mr. Adams nodding there. And he was employed as a contractor. He was an employee of UL, and he was employed by the Army in Arizona. Well, what's going on in 1942, 1943? A little skirmish was going on, right, around the world, and there was a real shortage of copper. Imagine that. A lot of brass being made for things that go bang. So here's Herbert working on Army facilities in Arizona, and he can't get any copper, and he can't get a ground. So he gets this little light bulb effect over his head, and he says, well, I'll just use the rebar. Sure, it gives you a little bit of a ground, and concrete will dissipate a little bit of power. And he worked feverishly for the next 20-some years to get it in code. Problem is, when it takes a lightning strike, if there's any residual moisture around that rebar and it heats up, you're going to have a major expansion of that moisture, and it's going to destroy your foundation. And that has happened in a lot of places, and I'm surprised it's in code, but it is. Builders love it. That's the last major improvement in grounding since then. The Chemrod has some great ideas. Have any of you, do you all know what a Chemrod is? Y'all have seen them? Have you ever seen one that's been maintained? I've been to hundreds of sites that have Chemrods. Well, the old ones had a copper cap on a copper tube, threaded. What's going to happen when you fill that with salts? It's going to seize shut, isn't it? At one site in Mobile, a gentleman took a breaker bar, trying to get the cap off, took a breaker bar and welded it to the, not welded it because you can't do it to copper, but he attached it in a nearly permanent fashion to the cap on the Chemrod, and then hooked it up with a chain to his truck. All it did was spin the entire Chemrod in the ground. He could not get the cap off. Well, you have to take the cap off to put salts in it. When the salts are gone, all you have is a copper pipe in the ground without even a point. It's just a pipe. It doesn't work. So anyway, Chemrod's a great idea, but you got to be pouring salts in it at least once a year. So the newer ones have plastic caps on them and they don't get hung up, apparently. That's not to disparage any competing systems. I'm not trying to disparage anybody. It's just there are pluses and minuses to everything. And we'd like to see grounding take a leap forward to protect electronics. Nothing in traditional grounding can handle the frequencies that are causing problems for electronics. In the earlier presentation that I was attending today, apparently the Insurance Information Institute has now increased the figure. They had a 2016 figure for annual claims for insurance for lightning damage. In 2016, it was just a little under $1 billion in the United States and around $4 billion globally. According to this particular presentation that was made by Lure Lightning Protection in Richmond, the III is now saying $2 billion in the United States. They don't have a global figure. That's a lot of money for lightning damage. Is that, and only a part of that is structural. The vast majority of it is on electronics. Because they're just being totally fried by traditional grounding that can't get rid of the power. And it's not the tower strikes again. It's mostly coming from inbound commercial power or telephone or cable Anyway, those are always commonly bonded with your electric ground. That's the cheaper way for them to do it. So they have virtually no protection on their wires. You get a lightning strike near a cable line, it's coming into your building. This we don't want to have happen. I've talked myself out and I'm a little bit late.
Yes, you have mentioned that you have to go to something here at the top of the hour and a little bit past that. Tom, I really want to appreciate the fact that you took time to talk with us and help us appreciate what you're doing. And folks can go to your website there, groundlinx.com, or send you an email directly.
Let me interrupt and add one thing real quickly. In about 10 days, don't go to the website right now. It's old. In about 10 days, we'll have our new website, same address, but it is far more informative, works a lot better. Our first website we did about 4 years ago, and we wanted to tell the story to everybody in every gory detail. If you want to fall asleep, read the old website. It'll put you to sleep. The new one will be a lot better. Hold off on that for about 10 days, and it should go live in about 10 days. But in the meantime, ask any question you want on that email address. I will respond to all of them as fast as I possibly can.
Again, thank you so very much for being with us, and we'll look forward to more. And again, as you and Ken were talking, making some arrangements for smaller radio stations that might want to get started and take care of that ground line, or just get their ground system in order.
And I would put this out there as a general offer, not a blanket offer, but let's talk about, if anybody's interested, if you want to help us do research, we'll make sure that you're accommodated, if you know what I mean, such that if you want to partner with us and help us find out a little bit more about what's going on and what the actual behavior is, we'll make sure you get the equipment to work with. How about that?
Sounds good. Thank you, Tom.
Thank you all very much. I appreciate your time very, very much and look forward to seeing you all again.